Hey there, welcome to dotnetFlix. We are talking about blockchain with Sander Gerz. And in the last episode we learned all about how you can use the Azure Blockchain Service to create a fully managed ledger in the cloud. And in this episode we will look into actually developing some blockchain solutions, right?
Exactly, yes. So as I mentioned in the previous session, there's a blockchain service and there's Azure Blockchain Workbench.
Mm-hmm.
And also, not in this slide, there's a Visual Studio Code extension.
Mm-hmm. And that's more for creating smart contracts, right?
Yeah, so these are the three components of an enterprise blockchain application. You have to launch and manage it, you have to model smart contracts, test it, try it out, and you have to build and extend the application. And these are the components that you would use for those different tasks. So now we're going to look at Azure Blockchain Workbench, and also we're going to look at the Visual Studio Code extension, the blockchain development kit for Ethereum. So let me start with the Workbench. Azure Blockchain Workbench, as its name explains, it's an Azure service. And the Azure Blockchain Workbench allows you to create a blockchain application that is obviously built on top of a blockchain environment, but also exposes an API.
Okay. And does this also rest? Does this always rest on top of the Azure Blockchain Service, or could you also use other ledgers to build an application with this workbench? Are they tightly integrated?
They are integrated.
Okay.
Yes, they are integrated. There are plans of extending out to other services, but at this moment, the integration is specifically within Azure.
Okay.
And that makes the most sense for most scenarios. One of the big problems in a blockchain or hazards is that if you lose your private key, you lose access.
You lose your blockchain.
You lose basically.
You lose. So that's something you need to be very careful about. And Blockchain Workbench allows you to store the private key in Active Directory, so that if the user moves on to a different job, for example, or is not in the organization anymore, you can still access the data.
Which is nice.
Which is nice, exactly. So to create the Blockchain Workbench environment, you need to just fill out a basic number of steps. You need to prefix the resource, create a username for the VMs that are using. Let's see. Still not good enough. 12 characters long.
Okay. Go for the 72 one.
Yeah. Now I have to confirm that. Okay, this is a challenge.
You've just added 1 to 3, I guess, to the end.
No, I need to copy this from. I'll just copy this from. From my.
Well, that's safer anyway, right?
Yeah.
Just use some password manager.
Exactly. So I just use these. I just used all the same passwords.
Oh, there goes the safety.
Yeah.
So do not do that in production. But
you should probably, you don't usually do that in production,
right.
But you can do it here. And you can create your user resource group and the location. Just click OK.
So what's the difference between the deployment region and the location? Or was the last thing that you added the location of the resource group?
Yes, the location
okay.
of the resource
Yeah,
group.
yes.
Yes. And so this is an interesting setting. I can either create a new blockchain network or I can use an existing. And in the previous episode, we created an Ethereum-based blockchain service, so we can use that same same endpoint here as well. And to do that, this is my blockchain service, and where are my nodes? Here's my node, and I can use this address to connect here.
Yep.
And so this is important because this gives you effectively access. This is an API key that you can that is used.
Yeah.
So it's not like if you see that this is a public address, this here. So if I connect to this address, I don't want to have anyone with knowledge of the address have access to my blockchain.
So you should have some kind of not authenticated or some error coming
Exactly,
back.
exactly. So you have different types of authentication. You can have basic authentication if you want.
Okay.
You have access keys, even firewall rules, etc. So I can do that here. I can also add the Azure Active Directory settings, and to do that I need to create an application which is a reference to the API that you would use. So I'm not doing that right now, but you can enter your domain name and the application ID. I'll just do that something here. So we can at least go to the next step. If you go to app registrations, I already created this. I have here an application ID, and we'll use this one here. Okay, and so this is running the final validation. You know, if I want to use an existing network, what domain name do I use, application ID, etc. So if I press OK now, nothing happens yet because I still have to give permission, etc. So this creation takes about 20 minutes. And what you'll end up with is a lot of resources. And that's why it's important to have all that resources in a resource group. Because you have 22 elements now in your Azure Blockchain Workbench environment. Most important parts are the app service for the public website and the app service for the API. All the other stuff is needed as well. One thing to note is that you have a SQL server, because a blockchain, while you can query a blockchain, it doesn't have a very user or developer friendly interface. So a SQL server is used to store transactions and more or less create a sort of an explorer on the blockchain.
Okay.
And if you've done all this, then you end up with a public website, and this is the example of the public website. It gives you I've uploaded a contract just to show you what happens, and these are the various stages of a contract.
Okay.
Now, why it's nice to have this interface. It's, for me, I don't think it's useful for an customers, they won't be using this. This is good to at least have something, but for your own custom application, you would probably use the API.
Yeah.
And that's also an app service, and it's the same API is also used in the background of this Workbench application. So this is a contract. How does the contract get there? Obviously, you need to upload. That's a bit fast. To deploy a new application on the Azure Blockchain Workbench, you upload a configuration file that basically says these are the methods that are available in the contract. These are the parties involved in the contract, and basically it's a JSON file. I'll show you later on, and the contract itself. So that's an example of a contract, and I can deploy this, and it will be, well, this time it was already deployed, but you get this.
Yeah.
Okay. So how do you create a contract?
Yeah, so one question about the Workbench, because previously I thought that the Workbench was something you would work with while developing your solution until you were ready to deploy it to production. But I guess the Workbench, you also deploy the Workbench to production so that your line of business application can use the API of the Workbench, which makes it easier for you to actually integrate with the blockchain itself, right?
Yes, exactly, exactly. Yes. The Azure, the Workbench is just a layer on top of a blockchain to make it easier for you to develop against the blockchain.
Yeah. So it's a kind of integration service, logically. Yeah.
Yes.
And I also see something like updates here, so you can also version your API and
you can
increment the version of your blockchain API.
You can add new versions of the contract.
Nice.
That's
cool.
Yeah. But before you get to this part of uploading and deploying your contract, you obviously also need to create a contract, and for that I'm using Visual Studio Code, because within Visual Studio Code you have extensions to basically build your contract in the programming language for smart contracts, which is Solidity. And in this example, I have a contract that can do original content copyright checks, which is very simple. It's just a storage method to store a unique hash of a certain content in a blockchain.
Okay.
So this way you know that at this point in time, this piece of content was effectively known and stored in a blockchain. If somebody later on disputes the rights to content, you can say, no, I created that content, and this is the proof that I created that content.
Yeah.
That's just one example. Another example of a contract is this one I created, which is for publishers that want to engage authors to create content.
Okay.
And say you have a publisher who says, I have a magazine and I want to invite authors to write for this magazine. The publisher can instantiate this contract, invite potential authors to submit a proposal, and everyone can see what's going on with that proposal. And eventually you can also transfer a reward once the contract content is accepted, for example.
Okay.
So this is a large piece of code. I'm not going to show you all the code, but what I want to show you is that in Visual Studio Code you have the extension. If you just type in blockchain, you got a lot of extensions. What's important is the Azure Blockchain Development Kit for Ethereum. And once you have this installed, what you can do here is you can build the contract,
Oh, okay.
you can deploy the contract, and you can also show a smart contract interaction page. Now, if you want to deploy a contract, you need a way, a service
Yeah.
where you want to deploy it.
Mhm.
Now, I have two options. I can either deploy locally,
Yep.
or I can deploy to my blockchain in Azure. And for just to show you what I'm using, or what you should use for deploying it locally, is Ganache. And Ganache is an application that is very easy to create your own blockchain locally.
Okay.
It's simply you can create a new workspace. You can add your project. So, for example, if I add this project, then everything you see in Ganache will reference to this project.
Okay.
I'll show you what that means. Now, this is some information that you need to be aware of: the port number, the network ID. Every Ethereum network has a network ID, accounts and keys. That you can basically skip all this. This is important to know.
Yeah.
Save the workspace, and you start out with a number of addresses and Ethereum that you can use. Now, for the purpose of this application that this smart contract that I have, I'm not using any Ethereum, but sometimes you do.
And that is the currency.
That's the currency, yes.
Yeah.
So in a public blockchain, if you want to deploy a smart contract, because that smart contract is consuming CPU power,
Yeah.
you need to also reward the computers that are actually giving you that power.
That's the mining part?
Yes,
Or-
that's the mining fee.
Yeah.
Yeah, and for Azure Blockchain, you don't have that mining fee. I mean, that's basically zero. But because this is a general tool, if you're building a smart contract and you test it on Ganache and you see that this would be like would take a lot of CPU power to consume, it would show that your balance is going down quickly,
okay.
and you maybe need to change your contract to be more efficient.
Yeah, so you can use it as a performance test.
Exactly. Yeah. Exactly. So if I look at my config file, I have this is my configuration for the blockchain service that is in Azure, and this is for development. And you see here I have the host name, I have the port number, and I have the same network ID. So this means that if I deploy my contract, I can see here, I can either deploy it locally or I can deploy it to my Azure Blockchain Service.
Okay.
So now it's deploying locally.
And this is possible because you're logged on to your Azure subscription in Visual Studio Code, right?
Yeah.
So it knows these resources are out there.
Yeah.
Okay.
Yeah. And if everything goes well, my balance is down a little bit. I can see here the transactions, and I have 3 contracts that have been created, and these are the contracts that are currently in my local blockchain. And you can do the same thing in the if you want to deploy it to the blockchain service in Azure as well. Other things that are nice in this Visual Studio extension is that you can interact with your contract. So if I go to the Show Smart Contract Interaction page, I get a visualization of how to use my contract, which is very nice.
So this is something that an application developer could use to figure out how the contract works and what you need to supply.
Exactly. So these are the fields that I defined in my contract, and these are the methods that are available for me.
Okay.
Yeah. So that makes it very easy to test the contract. There's also debugging. I won't go into debugging, but you can also debug your smart contract, which is effectively not, stepping into the debugger as it goes through the creation or of the contract or the various methods that are used, but it's just redoing the steps. But it will show you what happens in your contract. And also you can create workflows for data publishing, event publishing, microservices, and allows you to, for example, create a logic app from within this. So that's very quickly a review of what you can do with Azure Blockchain Workbench and the Azure Blockchain extension for Visual Studio Code. Let me see. Here are a couple of resources that are nice if people want to experiment with blockchain options on Azure. There's the link to the blockchain development kit. There's the Twitter account for Microsoft Blockchain. And we will put these links in the show notes so people can access them easily. Yeah, okay, cool. And Block Talk is a more or less weekly show that gives you an insight into what the development team at Microsoft is doing with Azure Blockchain. Oh, nice. Yeah, kind of a community stand-up for blockchain. Yeah, although they're sitting down, but it's a stand-up, but sitting down. Nice. Yeah, cool. Okay. Well, that's about it. Cool. Oh, okay. Well, thanks so much. We are learning all about working with the blockchain. So we had the first episode in which we looked at the Azure Blockchain Service, the fully serverless ledger that you can use. And in this episode, we looked at the Azure Blockchain Workbench and the extension for Visual Studio Code. And with these tools, you can start building your own blockchain applications. So, pretty cool. Thanks, Sander. Thank you. Thank you guys for watching, and see you at the next episode. Bye-bye. Bye. Bye.